Hi folks, making this video here to be a video number 1 here on how to test for symmetry. So that's what we're going to be doing here in this video, is testing for symmetry. So first I want to do a quick overview of how you test for symmetry. So we're going to start by changing the sign on x. Notationally, that's what this kind of means. In place of x, I'm going to replace it with minus x. If you can take an equation, take the x, replace it with minus x, and you end up with the same equation out again, then the graph will be symmetric about the y-axis. If you can change y to minus y, get the same equation out again, then the graph is symmetric about the x-axis. If you can change the sign on both x and y, get the same equation out again, then you have a graph that's symmetric about the origin. Right? So I'm going to apply these tests of symmetry to various equations here, starting with this one. All right, so what does that look like? So first we'll test it for symmetry about the y-axis. We'll change the x, or we'll replace the x with a minus x. And then we'll ask ourselves, is this the same equation? And the answer is no. Right? Minus x equals 3y squared minus 7 is not the same thing as x equals 3y squared minus 7. So this thing is not symmetric about the y-axis. All right, test number 2 here. We'll change the y and replace it with minus y and see what happens. That equation is now going to read x equals 3 times minus y squared minus 7. Now, when we take minus y and square it, the minus sign becomes positive, so we just end up with 3y squared minus 7. This, right, and don't forget it's x equals, this is the same equation as this. So it has passed, if you will, this test. So this graph is symmetric about the x-axis. Third test, right? If you can change the sign on both of them and get the same equation, then you're symmetric about the origin. Now, it is possible to have something symmetric about the origin and one of the axes, but it's pretty rare. There's not a whole lot of graph types that are going to do that, so it's unlikely that this will work, but we'll give it a try. What does the test look like? So we change the sign on x and y. Now we can simplify this. Then we compare this to the original. It is not the same, so it's not symmetric about the origin. So I think in this example, we had one case of symmetry here. We were able to change y with minus y, get the same equation out again, so this thing is symmetric about the x-axis. All right, let's try another example. All right, let's try x squared minus y squared equals 4. Okay. All right, change the sign on x. Simplify it. Compare to the original. This is the same, so we have this graph is symmetric about the y-axis. Second test, change the sign on y. Simplify it. Now be kind of cautious here. This minus sign, let's leave it here. Minus y squared is just y squared. Compare to the original, same equation. This thing is symmetric about the x-axis. And after I made that comment about most of them don't have multiple symmetries, this one will. Change the sign on x. Change the sign on y. Simplify. This one is symmetric about both. So this graph is symmetric about the x-axis and the y-axis and the origin. All right. Try another example. Get rid of this. Try this one. All right. Let's change the sign on the x first. Now that's going to be minus x cubed, right? Minus x, and I'm changing the sign on x. Got to be very cautious with plus and minus signs with these things. Okay, minus x cubed, right? The minus sign, by the time you cube it, is minus 1. minus a minus x is plus x. Now we compare this to the original. Is it the same? And the answer is no. So this thing is not symmetric about the y-axis. All right, next test, we'll change the sign on y. Compare it to the original. All right, it's not the same. If I move this minus sign over here, it really makes it pretty glaringly obvious. Compare this to this. They are not the same. So this thing is not symmetric about the x-axis. All right, next test. Change them both. Be careful with minus signs. All right, this one will leave put for a moment. -1 cubed is -1. The difference between these here the minus sign has been cubed, right? And that will end up out front. And then minus a minus x is plus x. Now, if I take this minus sign and I divide it out, this is now going to read y equals positive x cubed minus x. We compare this to the original, and it is the same. Okay, so this thing has passed, if you will, this test. So this graph is symmetric about the origin. So purpose of this video is just provide some examples of how to test for symmetry. I hope that that's done that for you. Have a great day.